Lesson: Key terminologies and concepts in AI system operations. Artificial intelligence has become an integral part of numerous industries, leading to the demand for professionals who understand the intricacies of AI system operations. As part of the CompTIA AI SysOp Certification, mastering the key terminologies and concepts in AI system operations is crucial for professionals aiming to excel in this field. This lesson imparts actionable insights and practical tools, along with frameworks and step-by-step applications, allowing professionals to effectively manage and optimize AI systems. AI systems operate on a foundation of machine learning, data science, and computational algorithms. Understanding these core components is essential for professionals. Machine learning, a subset of AI, involves training algorithms to recognize patterns and make decisions based on data. Supervised learning, unsupervised learning, and reinforcement learning are the three primary types of ML, each serving different purposes. In supervised learning, algorithms are trained on labeled datasets, making it ideal for tasks such as image classification and sentiment analysis. Unsupervised learning, on the other hand, deals with unlabeled data, finding hidden patterns or intrinsic structures within the data, commonly used in clustering and anomaly detection. Reinforcement learning focuses on training algorithms through rewards and penalties, often employed in robotics and game development. Data science is another critical component, encompassing data collection, pre-processing, and analysis. Professionals must be adept at handling large datasets, ensuring data quality, and choosing the right features for model training. Tools like Python and R, along with frameworks such as TensorFlow and PyTorch, are essential for implementing data science techniques effectively. Python, with its extensive libraries like NumPy, Pandas, and scikit-learn, provides a robust environment for data manipulation and analysis. TensorFlow and PyTorch, popular frameworks for deep learning, offer high-level APIs that facilitate the creation and training of complex neural networks, enabling the development of sophisticated AI models. Algorithm selection and optimization are pivotal in AI system operations. Professionals must choose algorithms that align with their specific tasks and data characteristics. For instance, decision trees are suitable for classification tasks with interpretable rules, while convolutional neural networks excel in image recognition due to their ability to capture spatial hierarchies in data. To optimize model performance, hyperparameter tuning is essential. Techniques like grid search and random search help in finding the best hyperparameters, enhancing model accuracy and efficiency. In AI system operations, model evaluation and validation are crucial to ensure reliability and accuracy. Cross-validation, a statistical method used to estimate the skill of ML models, helps in assessing how the results of a model will generalize to an independent dataset. Metrics such as precision, recall, F1 score, and ROC AUC are used to evaluate model performance. Precision and recall are particularly important in scenarios like medical diagnosis, where false positives and false negatives have significant implications. Deploying AI models into production requires understanding of infrastructure management and scalability. Docker and Kubernetes are powerful tools that facilitate containerization and orchestration, ensuring that AI applications run consistently across different environments. Docker allows professionals to package applications with all their dependencies, creating a portable and reproducible environment. Kubernetes, on the other hand, automates the deployment, scaling, and management of containerized applications, making it easier to handle large-scale AI deployments. Real-world challenges often involve integrating AI systems with existing IT infrastructure. Professionals need to address concerns related to data security and privacy. Implementing encryption, anonymization, and access controls are vital to protect sensitive data. Furthermore, understanding regulatory frameworks like GDPR is crucial for compliance in data protection. Case studies provide valuable insights into the practical applications of AI system operations. For instance, Netflix utilizes a recommendation system powered by ML algorithms to enhance user experience. By analyzing user behavior and preferences, Netflix delivers personalized content recommendations, significantly increasing user engagement and retention. This case exemplifies the importance of data-driven decision-making in AI system operations. Statistics play a crucial role in decision-making within AI system operations. For example, according to a report by McKinsey Global Institute, AI has the potential to create $13 trillion in global economic activity by 2030, underscoring the importance of AI proficiency in driving business value. Understanding these statistics helps professionals align AI strategies with business objectives, ensuring that AI initiatives contribute positively to organizational goals. Finally, continuous learning and adaptation are vital in the dynamic field of AI. Professionals must stay updated with the latest advancements and trends. Engaging in online courses, attending conferences, and participating in AI communities foster ongoing professional development. Moreover, leveraging AI platforms like Google AI and OpenAI provides access to cutting-edge research and tools, enabling professionals to experiment with new techniques and methodologies. Key terminologies and concepts in AI system operations form the backbone of effective AI management. Mastery of machine learning, data science, algorithm optimization, and model evaluation is essential for professionals seeking to excel in this field. Practical tools and frameworks such as Python, TensorFlow, Docker, and Kubernetes empower professionals to address real-world challenges, ensuring the successful deployment and management of AI systems. By understanding these concepts and leveraging practical tools, professionals can enhance their proficiency in AI system operations, contributing to the growth and success of their organizations.